And now we're ready to start the last section of Chapter 8. Yay! So 8.6, this is all about modeling with trigonometric functions. And we're going to start out with some review on amplitude and period of functions. So here we have some problems. I want you to think about these for a second, and then we're going to look at them together. So take a second, look those over, try to review. How would you find amplitude and period? So here's the answers. Number one, amplitude. And amplitude remembers the height. And amplitude is always found in front of the trig function. So the 2, even though it's negative, the amplitude is always a positive number. So the amplitude is 2. And the period is 2 pi. Because the number in front of the x is a 1, and how you find the period is you take 2 pi and you divide it by b, and b in this instance is 1, so 2 pi divided by 1 is just 2 pi. Number 2, the number in front of the trig function is 2/3, so the amplitude is 2/3. 2 pi divided by 2 pi is 1, so the period is 1. Number 3, even though there's a lot of stuff going on here, the amplitude is always just the number in front of the trig function. So the amplitude is positive 1. The period would be 2 pi divided by 3, or just 2 pi over 3. Number 4, the number in front of the trig function is the square root of 3 over 2. Had to be creative about how I wrote that down. And the period would be 2 pi divided by 2, which is just pi. Number 5, let's look at this one. So the amplitude would be 1.4, because that's what the a value is, or the number in front of the trig function. The b value is a 1, so it'd be 2 pi divided by 1, or just 2 pi. And the last one, number 6. 2.4 is the amplitude, and the b value is 1.8. So you take 2 pi, divide it by 1.8. You could find the decimal value of that, or just leave it as 2 pi over 1.8. So our lesson essential question is, what are the characteristics of real-life problems that can be modeled by trigonometric functions? So what does this all mean? How are trig functions used in the real world, which is probably something that you are wondering. So let's look at that. So trig functions actually are really useful and used a lot in a lot of different areas. In one area, or one way that we will use this is if we have a sine function of a model, that we are able to find the equation, start with the amplitude and the period of the graph, and then write those equations. So let's look at these. Here's some models of some electric current that's shown on the oscilloscope screen. So some very useful information of some real-life data. So as we look at this, let's identify the amplitude and the period. Amplitude goes from -20 to +20, so the amplitude is 20. And now these are a little tricky because they are placed in numbers, not according to 2 pi, but you have to kind of think, okay, so where would pi be? Where would 2 pi be? So I just kind of mark that. So 3.14 would be approximately, I'm going to get a different color here. 3.14 is approximately like right in here, and 6.28 is through here somewhere. So then we could look and see how many periods there are from 0 to 2 pi. And we see that there's 1, and notice it's starting just a little bit before the peak. So there's 1 and 2 and 3 and a little bit more, which is kind of neat. It turns out that it is 3.14, so pi is the period. So then our function would be y equals 20. sine of pi. Now, there is a little shift. There's a horizontal shift to this because typically the sine function would be right here. And you could say, well, it's being shifted to the right, or you could say it's being shifted to the left. It's being shifted to the right, either positive 0.64, so that would be, whoops. I'm gonna go here and go x minus 0.6. Looks like it's a little bit more than half. So that's one way you could represent it. Another way you could have said is that it's adding a 0.4 because you could say, well, it shifts over here and it's being shifted to the left 0.4. So you could have said plus 0.4. Either way, they represent the same function. So let's look at this function here. So the height of it is 15, so the amplitude is 15. And the period here, if you look at 6.28, which is 2 pi, that is 1, 2, 3, 4, 5, 6.28 about, so the period is 2 pi. So then we have 15 of sine 2 pi. And then this one is also being shifted to the right. That's a 0.4 approximately. So let's say that we have a sound consisting of a single frequency. That is called a pure tone. An audiometer produces pure tones to test a person's auditory functions, and it uses a frequency of 2,000 hertz or cycles per second. This maximum pressure P produced from the tone is 2 millipascals. So we're going to write and graph a sine model that gives the pressure of P as a function of T time. So when we look at this, we are going to be writing our function, so the pressure P, and we're going to represent it as a sine function. So it's going to be let me rewrite that. Sine of some value of B times T. And we know that the maximum pressure is 2, so that tells us our amplitude. Our amplitude would then be a 2, and we are going to use that to help us find the frequency, because we know that the frequency is equal to 1 over the period. So if the frequency is 1 over the period, then we could think of that as being the inverse of the period. So instead of 2 pi over B, it would be B over 2 pi. Now we're also told in the problem that the frequency is 2,000 hertz. So I can substitute 2,000 for the frequency, and I get 2,000 equals B over 2 pi. And then to multiply both sides by 2 pi, I found out that B is equal to 4,000 pi. So that's what I put in my equation. So I come over here and I say P is equal to the amplitude. We're told that the amplitude has a max of 2. So it's 2 sine of 4,000 pi times T. Now let's answer those questions that are in your notes so that you can fill that out as we go through here. So the first one it says is for A, is this a sine or a cosine function? Well, that's a good question. If you're not given any clues in the problem, typically we sine is kind of our default. If it says obviously to use a cosine, then you do that. But look right here, sine. So we're told to use a sine function. So that is our biggest clue here. We're going to use sine and not cosine. So part B says, what's the amplitude? Well, we answered that already. The maximum it gets is 2, so that's an amplitude of 2. C, the midline, and this hasn't been shifted up or down any, so the midline is at 0 or y equals 0. Question D in your note says, what is the period? We just found that out. The period, oh wait, no, we didn't find that out here. We do know what B is. B is 4,000 pi. So we do need to find out the period. The period, if you remember that formula, is 2 pi, whoops, that should say 2 pi over 4,000 pi. And if you reduce that, the pi's cancel, and the 2 goes into the 4, 2,000. So this is 1 over 2,000. So that is the period, 1 over 2,000. That's going to be really helpful when we graph it down here. So I'm just going to think of my sine function, and it's going to go through one complete period at 1 over 2,000. So that's really going to help me when I graph it. That's an awful graph, but we're going to pretend like that was really awesome. And then question E says radians per second, aka values of B. Well, values of B was the 4,000 pi. So there we go. There's all those questions answered. And that also helped us to figure out the graph. The amplitude is 2. The period was 1 2,000th. So a fourth of the way would be 1 8,000th. That's 8,000. And so on. That would be 1/4 or 1 4,000th. And then that would be halfway in between there too. Okay. Okay, so read through example 1b. We are looking for a function that will show this value right here, or this model. So first thing to notice, it says it's oscillates between -170 and 170 volts. So that tells me my amplitude. I'm going to make a note of that because I want to write that down. You grab my pen here. My amplitude, since it goes from -70 to 170, that means the amplitude height is 170. The next thing that I need to know is B. But in order to find B, I need to know what the frequency is. And frequency, as a reminder, our frequency is 1 over the period. 1 over P. And the frequency it tells me is 60. So 60 is equal to, and 1 over the period is the inverse of B over 2 pi. So to find out what B is, I'm just going to multiply both sides by 2 pi. So I get B equals 120 pi. So that's what our B value is. So our equation, and this is in terms of V, so voltage is 170, and we are using the sine function. It told us to use sine of 120 pi times t.